We are going to now use the combined gas law that we just talked about and do some calculations, answer some questions. So hopefully you made your foldable, and that will have all of your formulas and all of your units and everything that you need all in one place. So it'll help you out as you're going through this. All right. So we have our combined gas law again. P1 V1 over T1 equals P2 V2 over T2. And sort of the more you hear me say it, the better or easier it will be for you to remember it. So I'll just keep saying it. A little bit of a tongue twister, but we'll get it. Then we have the different solutions. So if the question asks, what's the new volume? We use the one on the blue sticker. It says, what's the new temperature? We use the one on the pink sticker. And so that's sort of how we can go about finding our answers once we know what we're looking for. So if we start with, and now this is example that is on your notes from the bottom of your note guide. That will have your questions, and then the second page has the other three that we're going to do here. Now, if you can print it, then print it and you can work it there. If you can't print it, then you can just do the work on a separate paper. And when I ask you to send me a picture of your work, you can just send a picture of the work that you did. You do not have to rewrite questions. It is probably going to be helpful if you list out all of the variables in the question, and I'll show you how to do that as I'm working these out. Okay. So we have this first question starts out talking about a helium balloon, like the one we talked about in the video. We start out with 50.0 liters. That's the first volume mentioned in the question. And the temperature is 298 Kelvin is our first temperature. And 1.08 atmospheres. Atmospheres is the pressure. All three of those things happen at the same time. So they are P1, V1, and T1. They're all related. Then the question asks, what volume? That's what we're looking for. So the second volume is our unknown. What volume will it have at 0.855 atmospheres? That's our P2. And I'm running out of space. And 283 Kelvin, that's our T2, right? So I marked it up. Now, if you don't have this printed on paper, you can't mark it up very well, but you can list all of the variables. And so you can do that same thing instead of marking. So our V1 is 50.0 liters. Our T1, 298 Kelvin, and P1, 1.08 atmospheres. V2 is what we're looking for. T2 is 283 Kelvin, and P2 is 0.855 ATM. So we have it all listed, or you have it all highlighted, whichever format you're using. Now we've got to rearrange the gas law. What are we looking for? And let's write it out that way. So we're looking for V2. So here's where we get our foldable. And since we are looking for V2, flip it up, V2 equals, and that's going to be the formula that we want to write to solve for V2. So V2 equals P1 V1 T2 over T1 P2. So we make it match. Rewrite the formula on your paper. Take out unneeded variables. That's a step that we're going to learn about next. So we're going to skip that one for now. And then we plug in the numbers. So we're looking for V2, P1, 1.08 ATM. Write the units. It helps you make sure you did things the right way. And then we have V1, 50.0 liters. And T2, down here from the bottom, 283 Kelvin. All over T1, 298 Kelvin. And then P2 is also on the bottom, 0.855 ATM. So let's look at our units, see what we have written, and make sure everything cancels out the way it should. So the unit atmosphere is on top and bottom, so that cancels. The unit Kelvin is on top and bottom, so that cancels. So the only unit left uncanceled is liters. That's our volume, so we know we've set it up the right way. Now we do the last step, plug it in, get your answers with units. So everything on the top, this is just like in our conversions, everything written on the top, you multiply. So 1.08 times 50 times 283. Now we're on the bottom, so we're going to divide. Divide by 298, divide by 0.855. Now when we look at sig figs, we have 3 digits everywhere in the question, so we're going to use 3 units in our answer. And the calculator has 59.978. We only need 3 digits, 1, 2, 3. So we're going to drop the 7, rounds up the 9, 9 rounds up the 9, and that makes it 60.0 liters. And there's our answer. The general steps that we've used, and they're sort of listed on the paper, but also here we can put them on the back of the foldable. So over here you can put steps that we follow, and we are going to add one to what's written here on the screen. So maybe hold off to put it on the foldable until you see the whole thing. But you read through the question and you want to identify all your variables, what each number stands for. Okay, now it may say the pressure is, and then you know that's a P. Or it might just say we are at 1 ATM. You need to remember atmospheres are pressure. And that was why we wrote that kind of stuff up on the top. So when it says atmosphere, you know that's the unit for pressure. When it says liters, then you know that's the unit for volume. So those are the guides on the top of the foldable, tell you what the variable it stands for. Is it a P, a T, or a V? So you can always match them up. So you identify your variables, and then you're going to write your combined gas law, and then rearrange it, use your foldable again. What are we solving for? That's the one you're going to use. We plug in our numbers and we get an answer. So then we can work this second problem and go through it. So this is the second one on the handout, or if you're not printing the handout, just copy it from here. You can work right from the screen. Remember, you don't have to write the question. You can just write a table kind of thing and list the variables that you're given. All right, the next problem. So we're going to follow our steps like we listed, and we'll get our answer again, just same process as we did before. So let's go through and identify the variables. So we have 700 milliliters. That's our first volume. And we are at STP. Now remember, we talked about STP before, and we said those are standard temperatures and pressures. So that stands for the numbers that we're going to use. And I'll write those out in a second on the side. Okay, that is going to be compressed to a new volume. The second volume is 200 milliliters. The temperature is going to be 30. And we are looking for the new pressure. And we have to get our temperatures all into Kelvin. So let's do that real quick first. Remember, it is 273 plus 30, and that will be our Kelvin number, 303. That's our real temperature here. All right, so let's lift them off on the side. V1 is 700.0 milliliters. STP, the standard temperature is 273 Kelvin, and the standard pressure is 1 atm. And we talked about that last week, and we also wrote that out, remember, in our foldable. So standard pressure, standard temperature. We're not using millimeters in this one problem today, so we don't have to worry about it. ATMs is where we are. And there we go. So that's our conditions in the beginning. A new volume is 200.0 milliliters. And the new temperature is our 303 Kelvin. And the new pressure is what we're looking for. Looking for pressure. I'm going to take out the unneeded. We haven't done that step yet. We're going to plug in our numbers, rearrange, and plug in the numbers. So pressure is what we're looking for. Fold it up. Here's our formula that we're going to use. Write it out. P2 equals P1 V1 T2 over T1 V2. And you just got to slow down, double check, make sure that your units, P1, V1, T2, T1, V2, make sure that it all matches what it needs to be, because T1s and 2s get very confusing when you're working on them. We're not going to take anything out yet. That happens in the next question. And then we're going to start plugging in our numbers. So P1, 1 atmosphere. Let's see, 1 atmosphere is easy to work with. You like that. V1, 700.0 milliliters. T2 from the bottom, 303, the bottom of my list. All over T1 from the first situation, 273, and V2, 200.0 milliliters. So write your units, and that way we can cancel them and check that we're doing it all the right way. So atmospheres, there is no atmosphere, so we're not going to be able to cancel that. Milliliters has milliliters. Kelvin has Kelvin. So the unit we're left with is atmospheres, and that's P2. That's what we're looking for. So we know we set it up the right way. And now we're going to plug in the numbers. Remember, everything on the top is multiply. Everything on the bottom is divide. So our 1 atmosphere times our 700 milliliters times the 303 Kelvin, go to the bottom, divide. 273, still on the bottom, divide 200. Our answer is going to be, and now we go to what we're given. 4 digits, 3 digits, 4 digits. 3 is going to be what we use for our answer. And so we have 3.884. Dropping the 4 doesn't change anything. So 3.88, and the unit we had was ATM. So our answer is 3.88 atmospheres of pressure. This type of question, if we read through it, we notice there are some things missing. So it says a sample of oxygen has a volume of 150, a volume, when its pressure is, here's a pressure, and then it says what's the new volume going to be when the gas has changed its pressure if the temperature stays the same. So the temperature isn't changing. So there's no T1, T2. It's a constant thing. So we can just leave it out. So really, this is going to be like a Boyle's Law question. But we don't have to worry about knowing names or anything. We just know T isn't changing. Drop it out of the question. So that's that step that I said that we could use some of the time. And so it shows up on our next slide. So we read through the question, identify our units, write your combined law, and take out what's not used. And we haven't done that yet, but we're going to do it now. So I put it in bold on this slide. So make sure you add that to your steps, because sometimes you won't have all three variables. You're only going to have two to work with. And that just makes it go faster. Then you rearrange and plug in, and there you go. All right. So let's work one of those type problems. That's the next one on your handout. So I will close this out, get my screen. All right. So now we're going to do this one where we don't use temperature in the question. So we have a sample of oxygen. It has a volume of 150, V1. Its pressure, 0.947. What will the volume of the gas be when the pressure is changed to 0.987? So we are looking for our volume. That's our unknown. So we've marked it up, identified things. We've got V1, 150.0 ml, and P1, 0.947 atm. V2, we don't know. P2, 0.987. There is no temperature. All right, so let's rearrange our gas law and solve it for volume. So we get our foldable and we find our volume solution, and there is no temperature mentioned, so we're not going to write temperature in the equation. It's going to be P1 V1 over P2, and that's all we have to worry about. So the V2 is P1 V1 over P2. It's the gas law without temperature, because temperature is not changed. So we've rearranged, took out what we didn't need. Now we plug in our numbers. V2 is P1, 0.947 atm, times V1, 150.0 ml, all over P2, 0.987 atm. When we check our units, atms cancel, and we have milliliters left, and that's volume, so it's all set up the right way. And so now the last step, put everything in the calculator. Numbers on the top, you multiply. 0.947 times 150, divide by 0.987, because it's on the bottom. Make sure you hit divide, equals, and everything we have 3 digits, 4 digits, 3 digits, so 3 will be what we use. 3 is less. When you look at your calculator, 3 digits is 143.9. Drop the 9, we round up. 143.9. We're keeping 3. Dropping the 9, we round up. 144 milliliters is the unit. Okay. So when you only have 2 variables given, you get to take something out and leave it out. And that is the way the next one works as well. All right, and our last problem, we're going to go through and identify our variables. I'm going to go shush the dog. All right, so this is our fourth problem. A sample of neon gas occupies a volume of 752 milliliters volume at 298 temperature, what volume, that's what we're looking for, will the gas occupy at 323 Kelvin, our T2. So if we make our list, V1, 752 milliliters, T1, 298 Kelvin, V2 is our unknown, and T2 is 323 Kelvin. Next step, rearrange the gas law. So we are looking for V2. So we're going to use the volume flap. And here's our equation. And we have volumes and temperatures. There are no pressures. So we're going to take those two units out. And we're going to use V1 T2 over T1. And that's the formula to solve this question. So our rearranged V2 is V1 T2 over T1. And we took everything out we needed to. Next step, plug in the numbers. V1, 752 milliliters. T2, 323 Kelvin. All over T1, 298 Kelvin. The 2 kelvins cancel, so we have milliliters left. That's our unit for volume, so we know we've set it up the right way. Now we're going to plug everything into the calculator. Top numbers you multiply, 752 times 323. On the bottom, divide 298 equals, everything is 3 digits. So we're going to use 3 digits for the answer. So we have 815.0, 815 ml. Answer for the volume in the new sample.